Hi everybody, welcome back to my channel on Feynman integration. Today we're not going to be doing an integral using the Feynman technique. Instead, we're going to be discussing the Weirestrass substitution that we will be using in future videos. The Weirestrass substitution is also known as the tangent half-angle substitution, or I think sometimes the universal trigonometric substitution. But anyway, it goes like this. When you're doing your substitution, and by the way, this substitution is used when you have the integral with an integrand that has trig functions in it, but not much of anything else. And at the end of this, I want you to use what we've learned to solve that integral. You can see that's a pretty daunting integral to solve if you don't know this trick. But anyway, so what you do is you make the substitution u is equal to the tangent of x over 2. And I represented that fact here in this triangle. U over 1 is equal to the tangent of that angle x over 2. And from there, just do a little manipulation on that. You get 2 tangent inverse u is equal to x. You get that by taking the arctangent on both sides and then multiplying by 2. And from there, it's easy to get dx is equal to 2 over u squared plus 1. Okay, so now, since we have this triangle based on the fact that the tangent of x over 2 is equal to u, we can come to the fact that sine of x over 2 is equal to u over the square root of u squared plus 1, and that the cosine of x over 2 is equal to 1 over the square root of u squared plus 1. And I hope that's easy for you to see right there. And now a couple facts that you learn in trigonometry. We know from trigonometry that the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. And we also know that the cosine of 2 theta is equal to the cosine squared of theta minus the sine squared of theta. So we're going to use that fact to solve for sine x and cosine x, because right now all we have is sine of x over 2 and cosine of x over 2, and that's not very useful. So, using these facts right here, we know that sine of x can be written, I hope you agree, as sine of 2 times x over 2. So writing it that way gives us this form, sine of 2 theta, which in this case our theta is x over 2. So that'll give us that sine of x is equal to 2 times the sine of x over 2 times the cosine of x over 2. Well, we know these two things, and if you multiply them together, you get this. Of course, it's 2 times that. So yeah, if you multiply sine of x over 2 times cosine of x over 2, you can see that you'll get u over u squared plus 1, and then of course you have the factor of 2. And then you use the same thought process for cosine of x. You know that cosine of x can be written as the cosine of 2 times x over 2, and from this fact, we get that that is equal to the cosine squared of x over 2 minus the sine squared of x over 2, which is equal to this. And from there, it's extremely easy to get the tangent of x if you needed that. You just take sine of x divided by cosine of x, which looks like that would give you 2u over 1 minus u squared, but I'm not going to write that on the board. So anyway, that is a very useful substitution, like I said, for integrals where the integrand is, just has mostly trig functions in it. And I wrote down a common problem to solve using the Weirestrass substitution, and if you want, go ahead and use this substitution to solve that. And like I said, down the road we are going to be using this substitution to evaluate some Feynman integrals. But anyway, that's the Weirestrass substitution. Hope you learned something and hope you enjoyed that.